everybody. We are Lockrack. All right, from right to left, you'll see this is Adam, Dylan, Lauren, Derek, Dan, and myself, Chris. Now, how many of you guys brought a bike with you to campus this year? All right, so you see, not a huge proportion of the class to begin with. So far this year, we've had 6 of those bikes get stolen, just in the summer alone. So you can really see that our problem strikes home.
Alright, so as Chris said, bike theft is a serious problem on our campus. We contacted the UIUC Public Safety Department for statistics, and there are over 100 bikes that were stolen within a period of a year and a half. And that's only the ones that are reported, because most people don't go through the trouble of reporting because they didn't register their bike, or it's just like the chance of you getting your bike back is just slim to none. And our other problem is that current bike locks are really weak, they're easy to break, and they're also fairly expensive because the companies that make them want to gain a profit, and students have to buy that. And as you guys know, college students don't have all that much money. So our solution, we decided to use the bike itself as part of the system. So like the design of the bike to help secure the bike itself. And as an added bonus, we have a card swiper, which is going to increase the easy use and security.
So our project definition, the goal of this project is to make a lock that was both that was easy for the user, convenient, cost-effective in comparison to other racks and locks, and would be able to work with a university ID card as just a swipe method. Hopefully, if implemented, our lock design will help to decrease the amount of bike theft on campus and save students some money as far as locks go.
So the first couple of weeks, we took a look at different designs for our bike rack. The first design we had were 2 steel plates covering the wheels, which would stop both of the wheels and the frame. But we realized that was both too expensive and too many moving parts. So when we went back to the drawing board, we came up with this design here, which would put pressure down on the bike frame, thus disabling the thief from taking both wheels because of the axis, and it's more cost effective.
All right, so next, obviously our next step was a 3D model of the design. So first off, we start off with a 2D sketch. We extrude it to a 3D shape, and you keep doing this until you have a certain part. This is a part, and you have to assemble all these parts together. So this is before constraining. You can see those 2 parts are separate. You select the faces you want to be together, and you select the second face, you hit apply, and then they're together. So after doing all this, you get the finished assembly, which looks like this. And that is our finished assembly on the 3D model. Now we'll show you a video of how all this works. So first you move the bike into the little triangle you see here. Then you move the bike locking mechanism down on top of the top tube. You go over here, you select your iCard, which then would relay to a servo on the bottom, moving a pin into the locking mechanism with the teeth. And thus, when you go out, your bike is locked. Next, we wanted to make sure that our design was feasible with steel, so we wanted to do some sort of stress testing, so we made a 3D model of the pin. We applied a 500-pound force, because we figured that's about as much force anyone can apply upwards. We assigned the material as to steel, and these are our results. You see the colors here, they all mean something, but the most important most important number here is the minimum safety factor is a 1.9. This means that at the weakest point of the design can sustain 1.9 times the force of 500 pounds. So do the quick math there, and it won't fail. So this is very encouraging for us, especially since industries such as aerospace construction use a sort of standard as 1.9, 1.2 for buildings and airplanes and such. So this is kind of very encouraging for us and should work well with steel if implemented. We also had to address the concern about the card swiper. It's electronic, so you have to protect it from the weather. So we made a casing. You can see it there. Here's a 3D model of it, and here are the 3D printed parts, which then get assembled into what you see on the post now.
So originally we decided to make a model out of foam just to make sure that we could actually cut out and make our design and just have a visual representation of what it was we were making as we worked on the model that you see here. After that, we started making our wood model. Originally, we had wanted to make a model out of steel or some other metal, but ultimately it wasn't in our budget to do so, so we settled on wood because it was cheaper. We made the bar and cut out the teeth so that it could actually lock. And then we also made this stand here so you could see how the underground locking mechanism itself actually works, and mounted our locking mechanism to the board itself.
All right, so I did all of the programming and wiring for this project. Next slide. This is the basic design of the program, which is basically, it waits for a card to be swiped. When you swipe it, it goes through all the bits that the card swiper gives out, turns that into characters, and then stores it, because this prototype is designed to work with any card. It could be constrained to work with the subset of cards, but this one will work with any card. It then stores those characters as a password, turns a servo, which locks the bike into place, and then when it waits for another swipe. When you swipe again, it checks what that card says against the password you previously had. If it's different, well then it doesn't unlock. If it's the same, it unlocks and then deletes the password, therefore giving you and only you access to your bike. And there's a picture of all the wiring that goes into this. Now, we had basically two budgets for this project. We had the project budget and then what it would actually cost to implement the budget. Our project budget was a little bit higher than we wanted it to be because of failed servo, but we still stayed in a good range. And then the actual budget turned out pretty well. As you can see, for one lock rack made out of steel, it's actually only cost $66, which, considering how much normal steel locks cost, normal steel racks cost that they put around campus, this is actually pretty good in comparison.
Most of the problems we encountered had to do with our management of time and our management of the team, the ways of communication and such. And we were able to overcome these problems with relative ease, and we learned a lot from it. You can see some of the specific things we did there.
All right, now time to move on to results. We will show you how you lock a bike in the locker.
First, bring the bike in here, put the back wheel in the triangle here. Move that over the bar onto it.
All right, and then you take any card. You can use any card you want. I'm going to use my orange card in this case. Flip this open. Swipe. Electrician in his tower. Swipe. And now it's locked in place, and you can't get it out. If somebody comes along and tries to swipe another card, say their iCard, it's not going to lock for them until you come back and swipe your original card.
Unlock it. And the reason this design really works is because by putting pressure down, the way the axle is designed, you can't move the wheels out unless you lift the bike itself. So your wheels are secure, the frame is secure, it works.
Well, you had a budget for what one of these would cost just in materials, but did you do any research into how much it would cost to like actually install it into the ground? And
Yes, it actually is fairly expensive, but it is no more expensive than the racks they already put in campus. So this is simply just the cost over what you would already put in. Jason?
Just a concern, if somebody were to take off the seat, would they be able to slide the bike through, or?
Well, most bikes, the way they're designed, the seat post is always slightly higher. It doesn't map right on top to, so even then you wouldn't be able to take it out.
What if the bike has a suspension? Would you push the bike further down?
Yeah, if you really wanted to, you could push that further down. We're often not doing that because it's wood. But yeah, if you wanted to, out of steel, you could easily add as much pressure as you want. Charles?
Have you tried contacting anyone to actually get these bike locks installed into our school?
Not yet.
What if the top bar isn't like straight, like flat, what if it's at an angle?
Most bikes are either that from the headset to this tube over here. They're either angled down, so you could push this further down. I haven't seen a bike in which the top tube is actually slanted like so. In which case the design would work, but I haven't seen a bike like that.
Actually, having a wider V actually helps it lock more securely. You can get lower.
What's the power source on this? Because obviously if you don't have electricity, you can't do it like that.
The power would be coming from an external source.
Power is external, but it's a very low power system, so a backup battery could easily let you get your bike in a power outage situation.
For this design, we're using for double A's.
In your 3D model, you had a wider angle on this like hook.
Yeah.
Is there any particular reason why when you actually fabricated it, you made a closed angle?
Not really. Any sort of angle will work.
Yeah.
As long as it's not completely flat.
I think when we looked at the angle, we realized that it was a little bit too wide for most bikes actually made.
Somewhat also about compressing the size of the device itself. Any other questions? Jack?
I'm not sure on, like you mentioned this at the end, how the pressure on the tires prevents you taking the wheels off. How does it prevent the wheels from just like, especially like quick release wheels?
Yeah.
If you pop it off, you could just roll it out the front.
Well, the way the fork is set up, here, I'll do it online right now. You will take it off, right? But for you to take off this wheel, you have to lift the frame up. You can't, there's no way of taking this out from just moving it side to side. You have to lift the frame up in order to take out the wheel.
Okay.
If you remove the lock, I can take it out easily, but with the top of the frame locked in, there's no way of moving the frame up, so you can't take out the wheel.
Okay.
The same applies to the back tire, back tire as well.
Michael?
You convinced me on the mechanical safety of your system, but is it possible that the wiring could be manipulated, or how's the security on the electric part?
If this was implemented with steel, as is the plan for actual implementation, the wires would be inside the steel surface. So in order to get to them, you'd have to cut through a lot of steel, much more steel than you would actually have to cut through to just tear the bike apart in the first place.
What if I had lost the card that I used to lock it? Is there a way to get around that to get the bike back, or do I have to go get another card?
Because this would be implemented by a large organization as a whole, there would be the same sort of authentication process as say you would go through for losing your room key.
If this is implemented on a larger scale, each lock rack gets a single swiper, or is it there a central hub? Or
It would depend on who implements them, what they want to do, but it's very likely that they could set up a system similar to parking garages, where they just have a big central system where you type in your number and swipe.
is it cost effective then if each lock had its own swiper, or?
Yes, they're fairly cheap.
If someone were to slash the tires on the bike, causing the bike to drop down, and they could pull it out over they could pull the bike through underneath it if the seat was off, would the clasp come down harder on it, or would it just stay at that same level? Does that question make sense?
Yes. To be honest, we haven't thought of that, but we could easily implement that to design, considering that the teeth are made so that you can only, if you were to add a force and adjust the height of the thing, it would only be able to go down. So that could be easily implemented if need be.
Yeah, I don't know if you guys recall seeing the teeth from the thing, but our teeth are at an angle to where they can, as he said, they can only slide down. And that was actually after some debate, and that is the exact reason we did it, is we wanted it to be able to go down in that event. And the actual final steel design, there would be a spring or mechanism that would pull it down towards the ground, so it would have to be pulled up, or it would naturally sit down.
I want to know how much it costs to implement the cover rack. Because you said this is cheaper than cover rack. I want to know how much it costs.
When we looked up the prices, it was about 150 or so, yeah, for like a rack that had steel like this for about 5 bikes. So it's about 5/3 of the cost.
And that was just for that rack itself, not for the cost of the cement and stuff that poured.
Keep in mind, our rack has a lock built in, so it will be slightly more expensive.
All right, let's thank them one more time.